For those who didn't come, right, I hope you guys watched Dr. Lin Workshop 6 video already. Workshop 6 is about Struct. Struct is a very important topic in the sense that you need to write a linked list for your assignment. Your assignment is considered as your midterm. You need to complete your linked list, okay? Let me go through with you first how to write a struct and how to use it. Because this struct is very important, it will act like a foundation for you to write your linked list. If you don't know how to write a struct, you most likely cannot finish this linked list. So let's try and learn how to do a struct first. If you want to write a struct, right, a struct will have a structure like this. Normally when you write a struct, right, you start from a keyword called as struct, and then followed by the tag name. When do we need to write the tag name or not? If you are coming from Java background, right, you might know our Java is object-oriented programming. We have something called as class, okay? However, in C, right, our C is procedural programming. In procedural programming, right, you don't have an option, you don't have much option to write a class. But in our C, we got something called as a struct. The struct, right, is just like a class, okay? It's very, very similar to a class. The struct can help you to encapsulate, okay? It helps you to encapsulate the variable. If I have a struct of a tag name called as integer variables and character variables, right, it means, essentially, this simply means I have two declarations, okay? I have two declarations belong to this entity. After we declare this, okay, after we declare these fields, we can actually write something like this, struct followed by the tag name, okay, tag name followed by the variables name, result1, result2, okay. If you write result1, result2, right, then you can store the data like this. You type the variables name first, okay, result1, followed by a dot integer variables, meaning we are accessing these variables, okay, dot integer variable, then we store 100, and then result1 dot character variables is equal to a. That means, right, we are storing the a to this variables, okay. As you can see, if we declare like this, right, instead of having 4 variables, right, we just declare 2 struct only, okay. We just declare 2 struct. By declaring 2 struct, we can store 4 variables already. Can you see it? Second thing I want to introduce you is, if you want to copy result1, okay, if you want to copy result1 data into, say, result2 variables, you can directly use like this, okay. Remember this carefully, remember this carefully. If you write result2 is equal to result1, right, all the data in result1 would get copied, it is get copying, it's not passed by reference. Later I will come back in here. I want you to understand first. If you write result2 is equal to result1 data, okay, the data inside here would copy to result2. There is a performance impact if you write like this, because everything is get copying. If that understood, right, now I'm going to go through this one. What is the difference if you don't declare a tag name? If you plan to use your struct one time only, okay, if you plan to use your struct one time only, right, you can direct write like this, okay, you can direct write like this without the tag name, okay, without the tag name, only the variables name. If you direct write the variables name, okay, say I call this as result single, okay, result single. That means, right, I can only write one time. Result single dot integer variables is equal to 70. Result single dot character is equal to b. Meaning I can only use it one time only. Can you see the difference? The struct is very convenient in the sense, right, if you want to store 2 exam results, for example, instead of declaring 4 variables, what you can do is use a struct. Usually we don't write like this, because it's very, very messy. You see, it's very, very long, right? Usually we actually declare it in a header. To show you how to use this struct, right, when you want to print it, you can actually put the result1 dot integer variables and result1 dot characters variable. This is how to print it. If you want to use it multiple times, you write the data type name in here, okay? You declare the data type name here. Like I said, tag name is optional. You can write it also can. You don't write it, no problem also, okay? If you declare the type def like this, followed by the data type name, then in your main, right, you can write the data type name, okay, data type name followed by the variable's name, okay. Now comes the most important part. I want to talk about pointer, but don't be too scared, okay. Relax yourself, okay, relax yourself. There's no pointer diagram, so don't worry about it. You can also declare your struct, right? Remember just now, I actually defined the struct in the header already. When I declare the struct in the header with the data type name, right, I can also use the pointer, like a usual variable. For variables, you can also use a pointer, right? Similarly to your struct. For your self-defined struct, right, your self-defined struct can also use a pointer. There are a few reasons why do you want to use a pointer. If you write like this is actually considered quite inefficient. Why do I say inefficient? Because the entire result one, right, is actually copied into the result 2. Okay? The entire result 1 is copied to the result 2. If you don't want to copy, what you can do is use a pointer, okay? Use the pointer to refer it only. By using a pointer, right, result 3 is equal to address of result 2. Writing like this, that means we are refer it only, okay? Refer it only. That means our result 3, result 3 variable is storing the address of result 2, okay? Storing the address only, okay? Address only. Store the reference only, okay? Just store the reference. So we store the reference into the pointer only, okay? This is the first reason. There is another reason. We want to keep the struct in the memory, okay? Second reason is we want to keep the struct in the memory. In order to use this struct, right, you can also use a malloc, okay? You can use a malloc, okay? Malloc followed by the data type, okay? Followed by the data type. If you use the malloc, right, then you can use like this also, okay? You can use like this also. After you malloc it, I hope you can imagine something like this, but the right side is actually a malloc. The right side is a malloc, okay? Why do you want to malloc? If you use a malloc, that means everything will be kept in memory, okay? It will be kept in memory. So the example, you have another function, okay? If you have another function, right, you pass in these variables, the data is not lost, okay? The data is not lost. That's why there is a situation, okay? There is a situation where you might want to malloc the struct, okay? Especially in your LinkedList. In your LinkedList, right, you eventually use a malloc so that you can keep it in the memory, okay? If you declare as a pointer, how do we access it? Here comes the amazing part. For our struct pointer, right, there is actually a shortcut, okay? There's actually a shortcut. Instead of the reference, because of the precedency, okay? Because of precedency, right, we need to bracket the reference, okay? We must bracket the reference. But it's very tedious, right? It's very, very tedious. Each time we need to bracket the reference. So tedious, okay? So tedious. So luckily, in our C, right? In our C, we got a shortcut. If it's a pointer for struct only, okay? For the struct pointer only, for our struct pointer, if you want to access the data type, remember the data type is this one, this thing, okay? This thing. If you want to access this variable, okay? If you want to access these variables, right? You can use this symbol, okay, this symbol. You can result 3, you type a dot, okay, you type a dot, then followed by the character variables. As you can see, right, when I click on it, it will actually automatically convert it to this symbol, okay. You can use a dot, you can use a dot. That's the amazing part. How do we print a pointer? We use this symbol also, okay. This is like a dereference, okay, this is just like a dereference. If you use this symbol followed by the integer variables, right, you will able to print the result, okay. You use this symbol, you will able to print this result. So let's look at this code. Initially, I declare the data type of result 1, and then data type name of result 2, and then data type name pointer of result 3. I put it as address of result 2, okay. And then in the result 1, I store it 100 marks. The score is A, for example. and then result 2 is equal to result 1. Okay, as you can see, right, I already said it just now, this is copying everything lah. Sometimes, right, you will notice okay, it's really unnecessary to copy it because it's quite inefficient. Can you imagine if your struct, right, have a lot of variables, okay? If your struct have a lot of fields declaration, right, can you imagine every field get copied one by one. It's quite inefficient. So that's why you want to consider carefully when do you need to copy, okay? You need to consider whether you want to use a pointer or you want to copy the data, okay? This one, okay? After that, after I copy the result 1, is equal to result 2. Then result 3, right? Result 3, I access the integer variables, okay? I dereference it, okay? I dereference the integer variables, I store 70. And then result 3, right? I dereference the character variables, I store C. If I print this result, what do you think is the answer? 70 and C, okay? Because this is a pointer, The pointer, right, is address of result 2. If I write like this, when you dereference it, right, you actually dereference the result 2, okay? This dereference the result 2, and then we store the integer variables at 70, you store the variables at C, okay? In your assignment, say you want to separate to print, okay? You want to separate to print the struct, right? You want to be careful, you don't want to declare this result is a struct data type, okay? This is a struct data type, okay? I repeat again, this result is the struct data type. You don't want to write like this, okay? You don't want to write like this. Because if you write like this, that means, right, when you call the rest, if you pass the rest, okay? If you pass, you declare the main result rest. And then you call this function print result rest. Can you imagine? You call the print result rest, right? When you pass into this function, this rest will make a copy of this rest. I repeat again, this rest will make a copy of this entire rest, okay? You don't want to do this, okay? You don't want to do this. If you decided to write a function to print your struct, okay? If you decided to write a function to print your struct, right? What you want to do is use a struct pointer, okay? Use a struct pointer. So that when you use a result pointer of our rest, right? So you change it, just now is the rest only. Just now is the rest variable. Just now you pass in the rest variable. But now you pass in the address of rest. When you pass in address of rest, right? That means we only pass the address only, okay? This one, okay? We pass the address only. Pass the address to this pointer, okay? Pass the address to this pointer so that you only dereference, okay? You only dereference the pointer. You dereference the pointer, that means we are actually accessing this variable. Nothing get copied, okay? Nothing get copied. This is more efficient, okay? This is more efficient. This is what you should do in your assignment, okay? Always use a struct pointer, okay? Struct pointer, Take home message for you, okay? The take home message for you is always use a struct pointer, okay? Struct pointer. Another tiny trick, initialize the struct like an array. If you write like this, type that struct int mark char grade result, right? And then this is in the main, When you write result rest, right, you don't have to write this thing, okay? You don't have to write this. You can direct write like this, You can direct write like this. These 3 lines, right? These 3 lines, you can direct write like this. This means this is initialized, This is initialized. The same thing, okay? The same thing. By the way, this should not be 7, This should not be 7. This is a B. This is a B. Typo.